This conference will now be recorded.
Yes.
Hello. Okay. All right. So again, what I would like to tell you here is there are n number of different articles on garbage collection. If you start right from the scratch, if you want to understand everything with respect to garbage collector, right? It is like there is so much of stuff that has been discussed right from the scratch. If you want to become a GC expert, like a full stack developer, that is not really required from a performance standpoint of view. But however, you need to understand all the memory management models in Java. We already spoke about all the young generation, older generation, and permanent generation, but I would like to give an overview again before we go with the complete garbage collector mechanism. Okay, so in the memory model, the memory management in Java, when we talk about young generation, right? The young generation is the place where all the new objects are created. Okay, when this young generation is filled, the garbage collection is performed. Again, the garbage collection is nothing but collecting all the unused objects which are no longer being referenced or no longer used. What type of GC is performed in young generation? Anyone?
Minor GC.
Right, minor GC is performed, right? The garbage collector that gets kicks in when this memory area is filled with all the new objects. There is something called minor GC which will happen only on the younger generation. And this younger generation is divided into three parts. One is hidden memory and two survivor spaces. For this, you can directly give, there is a value called XMN value which will give the total size of younger generation. Got it? So in younger generation, we have three different spaces. One is Eden, one is S1, one is S0 and S1. Okay. Now, why do we have two survivor spaces? Anyone has idea?
Is it like a staging, like moving from one stage to next stage based
And
on the time?
yeah, we will talk about this point when I show it to you in real time. When I show you the metrics by using JSTAT, I'll show you. Okay. So when Eden space is the first space in young generation is the Eden space. When Eden space is filled with objects, minor GC is performed, and all the survived objects are moved to one of the survivor spaces. What you have to remember is you have two survivor spaces. One is S0 and one is S1. One among these two survivor spaces is always empty. Okay, whenever the promotion of objects is happening after some cycles of garbage collection, when the objects gets promoted after the minor GC from median space to survivor spaces, it moves the objects to any one of the survivor space, and one among the survivor space S0 and S1, any one among them will always be empty. Even I'll discuss this point when I show it to you. Okay, so at a time, one of the survivor space is always empty, and you need to understand why one of the survivor space is empty in younger generation of heap. Okay, this is another question. And which one is empty, S0 or S1? Let me open the diagram for you so that you'll understand it easily. Okay, and there is one article, his name is Pankaj. Okay, this is one of the top article that you have inside the how to do in java.com is one blog which will clearly explain you everything right from the scratch. Or you can also take the help of the dzone dzone articles with respect to Java. And there is one, well, let me a minute. Okay, general dev, this is the site. Okay, his name is Pankaj. You can also connect him on LinkedIn. So he has written very clearly this part. If you look at this table contents, how I mean how this garbage collection will work, what are the different types of garbage collectors you have, and he has written it very clearly like a textbook. It is very easy to read and understand, so you can go back and check this one. Okay. Okay, if you are you able to see this one. So what I'm trying to explain here is, if you look at the younger generation, if you give the value xmn, xmn is the value of the total young generation. Whatever the value that you give for xmn here, that value is fed for both Eden and survivor spaces that we have inside the young generation. And if you give this survivor space, sorry, if you give the survivor ratio of this younger generation to 2, for example, the total value of younger generation is 10 MB, to 5 MB will be for Eden, and 50% of the remaining is S0, 2.5 MB for S0, and 2.5 will be S1. Always the default value of the survivor ratio is 8 for younger generation. Okay, but most of the times the Eden, S0 and S1 as a best practice are given as survivor ratio as 2, because the total memory of this young generation, we try to make that as 50% of the total young. 50% of the total young goes to Eden, and in the remaining 50%, 24% of the memory goes to S0, and the remaining 25% of the memory is allocated to S1. Okay, and objects that are survived after many cycles of garbage collection, they are moved to older generation of memory space. Whatever the after completing of so many minor GC cycles on Eden, S0 and S1, whichever the objects are still not in use or not being referenced, they are promoted to older generation. Okay, usually this promotion will happen depending upon setting some threshold value for the age of young generation objects before they become eligible to promote to old generation. You understood, right? If the object has to promote from young generation to old generation, that object has to undergo some set of minor GC cycles. It means that this minor GC will happen on a very small amount of memory, and it will happen very frequently and very less period of time when you compare it with older generation. And basically this minor GC will not halt the application or will not stop. There is a concept of stop the world events. It will not stop any threads, it will not stop the application when GC is happening, and it will have a very low performance impact when this minor GC is happening. Okay, so to promote the objects from young generation to older generation, the objects in the younger generation has to undergo some set of minor GC cycles, and there is some threshold that you can set, like saying that if an object is undergoing 8 minor GC cycles, and if it is surviving after 8 GC cycles, then the object can be promoted to younger generation to older generation. If the value that you are setting to 12 or 15, it means that the object in the younger generation has to undergo some again 12 to 15 cycles. Then once it completes 15 cycles, the object will be eligible to get promoted to the older generation. For that, you have a setting, you can give the value, you can set the threshold, and you can make object to get promoted from younger generation to older generation. And the question here is, the interview question is, they'll ask you what is the parameter that you set the threshold. I mean, what is the value you basically set to give the number of GC cycles that can happen on younger generation? Anyone has an idea of what is that value? Anyone? No one knows that value? If someone is asking you what is the value that I can set, what is the name of that value and where I can set, you can use set environment variables in the WebLogic server. You can go back, you can go there, you can give the heap settings, XMS and XMX values, and when you give the sizes of young, older, and the perm gen spaces, right? Max tenuring threshold is the name of the metric that you have to set. It can be 10 or it can be 12 or it can be 15 depending on upon your requirement. You are setting that value on the young generation, so that what will happen is, if the minor GCs, the number of minor GCs, whatever you set, it can be 10 or 12, if that is getting completed, the object is survived for that number of minor GC cycles, and the object gets promoted to old memory. That is the value name. Okay.
Okay, what's the default value for the default number?
uh, it is like 8 to 12. It depends upon, it varies from JVM to JVM. Okay, because the functionality in different JVMs will differ. You have IBM JVMs, you have Oracle JVMs, you have hotspot JVMs. The functionality of different JVMs will vary from one to another. So most of the times, if it is an Oracle hotspot JVM, right, it is always like 15. 15 is the default number. Okay, and
Okay.
that also depends upon the allocation rate. Allocation rate is like, if you have some complex application, there are the three different phases of an object when it's created. Okay, so if the allocation is very high, right, then you will have high number of minor GC cycles. If the allocation rate of the objects is minimal or below the value that we have expected, then you can set 10 cycles. If the every 1 second, if for every 1 second, if it is allocating some 50 to 150 objects continuously, and the object allocation is rate is gradually increasing on the application, then then you have to give the number of cycles uh, depending on the allocation rate, depending upon the object complexity as well. There is something called immutable object. I'll tell you what it is now. Okay, so when we talk about older generation, now we are done with the younger generation part. When we talk about older generation, it contains all the objects that are long lived. Long lived is nothing but it has already survived many rounds of minor GC. Example, uh, someone asked me a question just now. The default value is always 10 to 15 cycles. Okay, you can set any number from 10 to 15 depending upon your allocation rate. You cannot set 2 or 3. If you are setting 2 or 3, it will not go more number of garbage collection rounds, and there are high chances of occupying the memory very quickly, right? So depending upon your allocation rate, the type of application, the complexity of the objects creation, the memory footprints, so the number of different complex use case traversals that you have using different emerging tech stacks in your application. So you keep all these parameters in mind, then you take a stand on what number of cycles you can set for the minor GC cycles. Basically, it is always 10 to 15 for any simple, moderate, and complex applications. Okay,
What is the value you
so
said?
sorry,
What is the value name you said to set that number?
max tenuring threshold. I have written
Oh,
it. I think it is already recorded. Okay, so yeah, garbage collection is completely, major GC is completely performed on the older generation of memory when it is full. Okay, this major GC usually takes a very longer time than minor GC, and when these major GC is happening, right, it generally happens on a very large amount of memory. If you take the Eden S0 and S1, the younger generation and older generation memory wise, it is high actually. The size of the memory is very high when you compare the older generation with the younger generation Eden S0 and S1. Basically, when this major GC is happening, right, uh, when this major GC is happening, it takes a longer time to clear all the objects and to free up the memory, it will take a very longer time at times, which will give you the high CPU utilization, high response times. At times, you will see most of the timeout errors. I'll tell you why. When this major GC is happening, any garbage collection, if you take minor GC, major GC, or full GC, any GC that is, if you take, all the garbage collections are called stop the world event. What is stop the world event? Anyone?
It will stop all event of the application server by performing
Means?
this. Uh, all application server itself halts. It will not do any operations. It will not give any response.
So if you have an idea, like all the functionalities or all the users or all the different activities that will happen in the name of threads, okay? We'll talk more about threads in thread dump analysis from tomorrow. But when you say stop the world events, right? All the application threads will stop when garbage collection is happening. It can be minor GC or it can be major GC or it can be full GC. Okay, so all the minor, major, full GC, whenever the GC is happening, this stop the world event will happen. It means that it will actually stop all the application threads until the garbage collection operation, garbage collector functionality, the task completes. Since the young generation keeps all the short-lived objects, minor GC will be very fast, and the application will not get affected by something called minor GC. Minor GC will, I told you right, minor GC will happen on a very less amount of memory. But major GC, it is not the case. Major GC, it will try to clear the memory of the long-lived objects. Okay, already the objects which has survived more number of minor GC cycles, it continuously tries to garbage collect. It will continuously tries to check all the object graph node. It will go to all the different classes, methods, static variables, everything. It will scan everything, and it will try to identify if that object is required or not, and accordingly it will plan to delete it from the existing memory. So basically, when this major GC is happening, right, all the threads will stop. There are high chances of having a very big performance impact, where the application can literally halt for some time, and whatever the time the garbage collection, the major GC is happening, the total time that it is taking for the stop the world events, it is also called garbage collection pause time. Okay, whatever the total time that it is taking, the same time will get added to the response time. If the garbage collection pause time is high, let's say that if it is somewhere around 9 seconds, and if your response time is 4 seconds, the total response time of that waited transaction will be 13 seconds, which is not acceptable at all, right? And when the GC pause time is going very high, when the stop the world events is, even that time is going very high, what will happen is you will see the throughput going down. The throughput will decrease, the performance of the application will decrease, and there will be another side effects like high CPU utilization, high memory utilization, and you will see a lot of timeout errors because of high GC pause time. So when you go to something called garbage collection tuning, the first answer of what did you do to improve the garbage collection mechanism, then your first answer can be like the major garbage collection should be reduced or optimized, because it will take the application unresponsive for the garbage collection duration. This is the only one point you have to remember. And remember, you will have some 50 to 60 points on garbage collector. You better try to understand what you need from the performance testing side, performance engineering side. If you again go back and look at every parameter that you have from the garbage collection tuning, right? You need to go with so many other topics, like what are all the different references that they use, how the object is created, what is the different footprints that that is being considered from. You have to start from the development, how the application is started, right from the first code. So for now, you can start learning Java, and for now, what you can do is, what are all the different types of garbage collections that you have, how they can work, how they can benefit if you're using a G1GC algorithm, or if you're using concurrent mark and sweep, what is the best algorithm that you can use, and what are all the things that you need to optimize. And when you come to this engineering part, you can understand which is a troublemaker, but you will not have complete access or complete control over these parameters to go and touch them, right? You cannot directly go and look at major GC, you cannot take that value, and you cannot directly optimize the code, right? You cannot reconstruct the objects which are troublemakers. That is not your scope. The scope of a performance tester and engineer is to identify what is the exact issue, and you need to get in touch with the respective development team, and you need to talk why it is happening and what is the permanent fix that has been taken. So in this context, in this direction, you need to investigate the performance issues, and you need to fix them, and you need to highlight and write them with the name called suggestions and recommendations, highlighting how the performance has improved with last release to this release, what are all the other actions that has been taken. Okay, so when I say that major GC has to be optimized, it is not you again who will optimize it. There is a respective team who will take care of the major GC time, who will try to reduce the garbage collection pass time, or the total execution time. So it is someone again. Okay, so if you have a responsive application and there are lot of major garbage collection happening, the only error that you always see is the timeout errors. Okay, the duration taken by this garbage collector basically depends upon the strategy and the GC algorithm that is used in garbage collection. That is why it is necessary to monitor and tune all the garbage collection to avoid timeout errors in a highly responsive application. If you take any banking application, which is doing a lot of activities in 1 hour. If you take any insurance based application, high sensitive based application, where you are selling some hundreds and hundreds of policies every day, if you take State Farm, or if you take any Morgan Stanley mutual funds or Bank of America, JPMC, any client, right? There are few applications which are continuously accessed. So for that high responsive application, high throughput generated application, if your GC pass time is high, if your major GC is taking very longer time, if your application is halting over a period of time, that will impact your performance. There are high chances of high CPU utilization, high memory utilization. There are timeout errors with respect to disk. There are some latency issues. You will get some non-HTTP 200 errors. Okay, the error rate is high, and you cannot give a conclusion saying that the application is passed or failed. The performance is not improved. Now, if you talk about the permanent generation, right? PermGen, PermGen contains the application metadata of the JVM. It means that it contains all the JVM classes and methods of all the programs that used in the application. Now tell me, PermGen is a part of which memory, heap or non-heap?
Non-heap.
Everyone knows that, right? PermGen is a non-heap memory. Heap is only Eden, S0, S1 and older generation. Okay? So, and this permgen, it will contain the classes and methods, and also the permgen contains the Java SC library classes and methods. Okay, on these permgen objects, the garbage collection that happen on permgen is nothing but a full GC. Okay, because the reason is, when you talk about this full GC, right? It the full GC even if the full GC is happening, there is no guarantee that the objects which are not being used or not being referenced will get deleted. Basically, the permgen will contain all the long-lived data. I mean, the continuously accessed data, all the main classes, all the main methods you will have in permgen. Completely runtime based related data you will have in permgen. So the garbage collection, the amount of garbage that is collected in permgen will be very less. It can be up to 3 to 5%. Okay, so you understood the concepts, right? Young generation, older generation, and perm generation. Now, if I talk about method area, I already told you about method area. Method area is a part of what? Non-heap. So, which is non-heap here?
Permgen.
Right. Method area is a part of non-heap. So, method area is now a part of permgen. Okay, method area is part of a space in the permgen, and it is used to store class structure. So there are, in the class structure, you will have runtime constants and static variables and the complete code information for all the methods and constructors. Okay, so most of the times people try to understand what is memory pool. Now tell me, what is memory pool here? Most of the people still try to increase the size of the memory pool in WebLogic or any application server,
Heap.
because yes. Any other answers?
Memory pool size should be including all the young gen and the old gen together.
Right, that's what I'm explaining here. Memory pool can belong to, it can be heap or non-heap. It means that it can belong to heap or permgen. Basically, this depends on the JVM memory manager implementation. You have different types of JVMs, and depending upon the memory manager that you have and the implementation that it has, this memory pool can be implemented on any of the heap or non-heap area. It can be also a part of perm, it can be also a part of eden or old, anything. So these memory pools are basically created by JVM memory managers, which are an inbuilt thing for every JVM. So to create a pool of immutable objects. Okay, so these memory pools are created for mostly for immutable objects. Now, do you have any idea about what is an immutable object?
Immutable in the sense we cannot grow further. It cannot grow
Im-
further.
Immutable object is nothing but the state of the object which is created remains constant after it has been entirely created. It means that basically these are used very much, very these are very frequently used in multi-threaded applications because they can be shared between threads without synchronization. And that means that if you have some public API of an immutable objects, it guarantees us that it will behave in the same way during its whole lifetime. You cannot change it at any point of time. Once it is created, it can be reused, it can be shared, and you cannot change the internal state of that particular object that is already created. Okay, so these memory pools are created by JVM managers only for the sake of immutable objects. If they, again, if the Java implementation, memory manager implementation is supporting it. Okay, if you want to know more about this immutable objects concept, this is a different concept in general dev. You can go and refer that. And if you talk about the Java stack memory, what is stack memory? I told you, right? Every stack memory will hold a
Local
instruction of
variable.
thread. Every thread will have a stack
Thread.
memory.
Yes.
So basically, this Java stack memory used for every execution of a thread. If a thread has to be executed inside the JVM, you need stack memory. Every thread will occupy some portion of memory in the Java stack. This Java stack will contain the method specific values and all the short-lived references to other objects in the heap. that are referred by every other method. Like it is talking about the entire object tree. Okay, so let me show this to you. Hang on. What happened? You're able to see my screen? You're able to see the metrics, right?
Yes, sir. Okay.
Yes, sir.
These are all you. I'll share you this document. These are all the metrics you need to set. Once you install, I'm not again explaining all these metrics now. The reason is because I want you to install Oracle 12c generic installer. I'll give you one WAR file. You can deploy it on your Oracle WebLogic. Okay, I'll tell you how to download that WAR file, how to deploy that application on WebLogic server, and how you can make this connection establishment of the application that is deployed on the web application server to database server. You need to establish some JDBC connection, right? I'll give you some properties. You do that exercise and check for all the values, and we'll have a mock round before we close these sessions. I'll give you some list of questions. We can have some interactions about all the questions, performance engineering questions that we are discussing. Maybe sometime next week I'll ask you what are all these things. Okay, what is the different parameters or what are the different metrics that you need to set. Okay, I already explained this. If you remember, the values are for permgen, xmn, size of young generation, survivor ratio. Still I'll send you all these metrics. We will talk more about it. Okay, so when now if we talk in specific about Java garbage collection, so we have already repeated the same thing again and again. It is collecting the unused objects. It is simply collecting the garbage to free up the space, to free up the memory, to be allocated to all the objects created in future processing. Okay, so one of the best features of Java programming language is automatic garbage collection. This is the assistant that is created by Sun people, and whereas this is the only advantage that Java has, because in any of the other languages that we have like C or C++, memory allocation and deallocation is a manual process. That is the not case in Java JVM concept. Okay, now if you talk about any object that is created, you will have a Java object lifecycle can be seen in 3 stages. The first stage of Java object lifecycle is object creation. To create an object, you use a simple new keyword. Object is equal to new object. Student s1 equal to new student, right? It means that you are creating a simple object. This is nothing but object creation. When an object is created, a specific amount of memory is allocated for storing that object. This amount of memory allocated can differ based on the architecture and the type of JVM that you're using. Okay, the same amount of memory will not the memory that it is occupying will not be same in every flavor of JVM. From JVM to JVM, and depending upon the type of architecture of the JVM, the amount of memory of an object that is getting stored will be different. Got it? And the second phase in the object life cycle is object in use. Okay, till the time object is used by application other objects, that means that other live objects which have references point to it. So during that object usage, object reside in memory and it may contain references to other objects. You got this point? So when you call an object in use, this particular object is already used by applications other objects. This object is already connected to many other objects that are already there in the application. That means that many live objects are pointed to the existing object, the object which is already in use. So when this particular object is used, this object which is residing in the memory, it will contain all the references of the application objects, which it means that all the live objects which are dependencies to this particular object which is already in use, they are already connected, they are already referenced. So if something is happening to this particular object, if any of the reference is breaking of this existing object, that piece of functionality which is supposed to work will fail. You will start seeing some errors. That is why the reason developer has to take some extra care when he is creating an object, when he is mentioning a particular reference to that particular object. For example, he will decide what is a type of reference that it has to hold. It can be a strong reference, it can be a weak reference, it can be a phantom, the different type of reference, right? He has to decide which type of reference that object has to hold. So based upon that, the object has to work, the object has to be live, as it will hold many references, many dependencies, and it has to survive the need of the end user for whatever the user is asking for. Okay. So the last phase is object destruction. Destruction, like the garbage collection system monitors all the objects through the complete object node graph, depending upon the feasibility, the counts of number of references to each object that it has. So when there are no references to any object, this is the only one single point the garbage collection will consider when an object is destroyed. Tell me when the object is destroyed,
If it has no reference.
right? It is simple. When there are no references to an object and when there is no way to get it with the currently running code, it makes a perfect sense to deallocate the associated memory which is holding that object. Simple. Okay. And the garbage collector, right? This is basically a background process. Okay. The garbage collector completely runs in the background. How do you make sure that garbage collector is running? Tell me how do you know how the garbage collector is running?
We can verify whether any process specific to garbage collection like daemon thread is running in the background.
Even you need not go with all that procedures. You can simply open JVisual VM and see the GC frequencies, the GC times. Any GC monitoring tool, any APM tool will monitor all the GC metrics. You need not worry. This is not. You need not investigate in many directions. The simple thing is you can use a JStat command. You can use JVisual VM. You can see JConsole, JProfiler. You can look at the memory allocations. You will easily understand how the garbage collection is happening, how it is taking place. Okay. Now, how does a garbage collection work? Tell me. I already told you in the last class. I remember garbage collection in basically it involves in 3 steps. How does it work? Anyone?
Sorry, RK, what I just missed the question. Okay, what is it?
Garbage collection mainly involves in 3 steps. Okay. Garbage collection will work on this type of mechanism. So what those 3 steps are?
It mark and sweep. First, it will go and mark all the unused objects. Then it will sweep out.
Okay.
So based on the threshold setup, the garbage collection will start in the memory.
So you forget about the type of garbage collection algorithm that you're using and the remaining points. I'll tell you 3 points now. Garbage collection steps. It involves in 3 steps. One is mark. The second one is delete and sweep. Okay, you can call it as delete or sweep. The third one is compaction. Okay, marking is nothing but this is the first step where the GC, the garbage collection, will walk through the entire object node graph. Starting from the root node, it will scan everything, and we will have some references to multiple objects, right, in the object node graph. So what will happen here is, in the mark phase, the garbage collector will mark all the objects that are reachable, and it will mark as live. Got it? Marking in one line, the GC will scan everything, and it will mark all the objects which are reachable, which are live, which are survived. It will mark all of them. The second phase is the delete and sweep. Okay, the second step. So here what garbage collection will do is, whichever the object is reachable, it is not touched. It is not touched, and all the unreachable objects are deleted, and it will reclaim the memory. Understood? And the last part, the last step is compacting. This is called compaction with fragmentation. So basically, the compaction is nothing but it is a process of arranging everything in order. This is our explanation. If you go back and look at all the different blocks, it is explained in n number of different ways. But for a very simple understanding, compaction is nothing but it is the process of everything. It is a process of arranging everything in order. So why I said process of arranging everything in order is because we will have randomly reachable objects in the grid, in the memory grid, where we don't have continuous allocation. So to avoid this fragmentation, the compaction will be done. I'll show you the diagram there so that you will understand. Like, you will have a grid, all the reachable objects are marked as live, the reachable objects are not touched. Whichever the object is reachable, it is not touched, and the unreachable objects are deleted, and it will reclaim the memory. So if you take a grid, if you take a box, memory box, which has some blocks in it, if you take the live object, reachable objects and unreachable objects, these reachable objects and unreachable objects are everywhere in the memory box, in all the grids. So when it is GC is scanning, when it is walking through all the object node graph, it is scanning all the objects which are randomly there in the memory box, in the memory blocks inside the memory, which reside inside the heap JVM. So it can clear any of the object, it can delete any of the unreachable object, it can reclaim the memory from any part of the heap memory. So when it is freeing up the memory at different points in the box, so the memory, the available memory will be in random places in the box. So what compaction will do is, it will bring all the available memory into one place, and all the occupied memory into one place. All the occupied memory will be arranged into the first order. This is nothing but fragmentation. So it will arrange all the occupied memory in the first block, and it will give the complete free memory in the second box. It means that to free up the memory, to arrange the available memory in one place, arranging all the reachable objects memory into one place, it will take a lot of time. Okay, basically when the garbage collection is happening, when you have high GC time, high GC pause time, when a major GC is taking a very longer time, it means that it is spending too much of time in compaction. Now you understood, right? In compaction, it is identifying all the objects, it is trying to fetch, it is trying to identify all the objects randomly which are available in the memory grid. So it collects all of them, the occupied, the living objects, the which are occupied into the memory, it brings all of them into one place, and whichever the memory is freeing up the memory, whichever the memory is available, it will bring it to one place. So to arrange all of them in one order, this process is nothing but compaction. The time spent on this memory arrangements of all the objects that are reachable is nothing but compaction. Basically, whatever the performance issues that you see, if your throughput is decreasing, if your throughput became constant, if your application is giving too many timeout errors, if you see high CPU spinning, if you see high amount of memory allocations, if you're seeing non-HTTP 200 errors, it is because of the higher stop the world events time, which is also known as high GC pause time, where all the threads will be stopped to execute this garbage collection process. Understood? One minute.
Yeah.
So now if we come to this part, memory management in Java, garbage collection types. There are 5 types of garbage collection types that we can use for applications. Again, don't go back. Let me show this to you. These are the important metrics, okay, that every APM will give you. I am copying here in the chat window. If you look, full GC execution time, minor GC execution time, full GC execution interval, minor GC execution interval, entire full GC, entire minor GC, GC execution time, full GC execution times. So all these metrics with some other additional metrics you can see in a APM like CA, Wiley, Intrascope, Dynatrace, App Dynamics. You can see all this. You will have some 15 to 20 metrics with respect to GC. And again, if you use JProfiler, your kit app perfect profiler, any profiler, you will see the main metrics, actual behavior. But if you want to investigate in all the directions, you have to look at all the different metrics, and you need to understand if full GC execution time is high, minor GC execution time is also high. Tell me what is the impact now? Full GC is taking high, minor GC is taking high. What can be the issue here? If you understand correctly, full GC execution time will take longer. That is a known fact, because it has to work on a very big memory, and it has to fight with the strongly surviving objects. They will not release. They are continuously accessed, and even GC is continuously running. Object is live. Object is still accessing something. It has some reference. It is not getting deleted. So out of 100 objects, 90 objects are still working. You will have only 10% of the memory, which will be a bottleneck. It there will be, the memory gets filled up very quickly, and even the GC is happening very often. It will not be able to free up the memory. Everyone knows that full GC will take a high amount of time. If minor GC execution time is taking very high, what does it mean? I told you, right? Minor GC generally doesn't take high amount of time, because minor GC will be very it will not give any performance impact, because it runs very fast, because it will run on a very small portion of memory. When minor GC is taking longer, it means that, what
The
does it
M
mean?
generation is either smaller, way too
Right,
smaller, or way too
right,
big.
you're right. Way too big, yes, it can be very small, it can be very big, or it can also be the problem with the type of objects that are created.
Yeah,
There is
huge
one
objects.
concept.
Yes. Yeah.
There is something called premature allocation. You know what is premature allocation? We'll talk about that. So, one moment, I got one email. Oh my god. Okay. So there are 5 types of garbage collections. For your better understanding, again, I have written it very clearly. If you are going to this article, right, you can simply crack the interview from GC side. Okay. Again, I'll share you one document. If you get some time, read that document. It's like a story. It's like a storybook. It is very easy to understand. You make all the points handy. So, I mean, if you make all the points handy before you go or before you give any interview to any client or any company, right? It will be very easy for you to crack because you need to understand the main points of the garbage collection. Even I see so many people having 1 year, 2 year, 15 years experience. They keep asking me, sir, do you have any interview questions? What do you do with interview questions? If I am talking about containerized Docker based environment, I'll ask you the Docker based optimization. No interview question will help you in any direction. Just preparing the interview questions will not help you, or it will not make you a very good performance engineer. What I want you to understand is you need to start from the basics. You need to understand the structure of the heap memory. Why heap memory? What is it used for? Why small amount of heap memory? Why can't we give the minimum and maximum of heap memory? Why we have to give older generation as I mean a big number to older generation compared to uh, younger generation? You need to know all these basics. You need to know the merits and demerits of giving the equal values to older and younger, or some value to older and some high value to younger. You need to understand all these things. What is live object? How can you create an object? What are the different types of objects? If you understand the object life cycle, the three main phases that are involved in garbage collection mechanism, you will crack the entries very easily. Even if I ask you, why are you using G1GC? Simple question. Why are you using G1GC algorithm? If I ask any one of you, you need not say garbage collection will involve in 3 steps: mark, delete, sweep, and compaction. I asked you, why are you using G1C? Why are you not using concurrent mark and sweep? If I ask you that, only one straight forward answer is mark, delete, sweep, and compaction is a process of any garbage collector. Any garbage collector will undergo all these three phases. But why are you using G1C collector? G1C collector, what it will do is it will have very less, it will spend very less amount of time on compaction. It will quickly arrange all the randomly reachable objects into one place and all the available memory into one place. If the other algorithms are spending 2 to 3 seconds of time in compaction, G1GC will not take less than 1 second. The time spent on compaction is very less in G1C algorithm if you compare it with other algorithms. That is what the answer that I am expecting. Okay, so don't prepare all these interview questions. I would strongly suggest you to understand right from the basics. The document, I'll share it now. If you read the document, you will get the complete idea of what garbage collection is. Okay, now the first you can read this things like live object is reachable and dead object is unreachable. Unreachable is not referenced and reachable is referenced. Okay, so I have written everything here, the basics of garbage collection. If you look at this one, this is how the memory is allocated. If you see, the memory is allocated randomly, right? All the black color is the allocated memory. Okay, after freeing the objects, you can see the black color here in white. After the compaction, all the blue color blocks are moved to the left hand side, and the white space is nothing but the available free space. After compaction, what happened? The free memory has brought all the free memory to one place and all the allocations to one place. The compaction is nothing but it is arranging everything in order, so that for the continuous allocation, only for the sake of continuous allocation, it will do this thing. This is nothing but compaction. Okay, so garbage collection, basically, why do you see high CPU utilization when the garbage collection time is, if the GC execution time is high, why do you see high CPU utilization? Look at the first point in garbage collection performance impact.
It involves computational resources.
So does garbage collection performance improve with the number of cores that we have on server? Yes or no?
Yes, that gives additional computing power.
Right. Using a 4-core CPU, 8-core CPU, and a 16-core CPU on a VM where your app server, web app server is installed, the garbage GC execution time will differ because the GC execution will need many number of CPU cores. Okay, if you have more number of CPUs on a server, it will take very less time to execute this GC. Okay, so mostly when you talk about the GC tuning or GC anything, right? You need to focus on minimizing or optimizing stop the world events time, which is also known as what? GC pause
Keep
time.
past time. Yes.
Right, right. Okay, so this is the hotspot heap structure, and you can look at this diagram. You'll understand it very easily. So all GC algorithms divide the heap into old and younger generations. You know that, right? And if we talk about the first algorithm, there is one metric in app server. I'll show you how to set this metric. -XX colon plus u serial GC is nothing but you are selecting that parameter to, you are enabling that serial GC. If you use this value in, I'll show you, I don't remember the parameter name. There is one value you can set it in the application server. If you go there and if you type serial GC, use serial GC, it will be using the serial GC algorithm in your JVM as a garbage collection algorithm. Basically, this serial GC uses the simple mark, sweep, and compact approach for young and older generations, for both young and older. When I say young and older, it is only talking about heap memory, not about the non-heap memory. When I talk about heap, it is talking about minor and major GCs. Okay, this is basically a single thread to process the heap, and the requirements are, you will the requirements are, it is mainly used in client machines, such as you will have some client desktop based applications, standalone applications, applications which are used over the intranet with a very smaller CPU, very small amount of memory. Basically with a low memory footprint, you can use serial GC. This is the first algorithm that came up with the very early versions of Java. Okay, for the very first time when you got a release with Java, it came for 32-bit JVMs with a single processor machines with a single thread. So in such cases, they used to use serial garbage collector for a very legacy based applications which are developed in the early 90s and 2000. Okay, so if you use this GC, you will have a high performance issues. It cannot handle any of the high memory requirements, any of the multi-tied environments, multi-based JVMs, and you will see so many pauses and it will directly crash. It will not even work efficiently on 64-bit JVMs. Okay, so you can forget about this part. So you have a throughput collector. In throughput collector, you have parallel garbage collector and parallel old GC. Okay, parallel GC is same as serial garbage collection, except it will run, it will use only one thread, but here it will be using some n number of CPU cores and it will use n number of threads, and the number of threads that it can use, you can set some value for that throughput collector. Okay, so for this also it is a single CPU environment, sorry. It is not a single CPU environment. So basically, it works on multi CPU, considering all the Unix, Linux, Windows, all 64-bit JVMs. Like it has been improved when you compare it with the serial GC. Whatever the serial GC is doing, it involves in minor, major garbage collections. It will run every. I mean, it will use all the techniques on both young and older generations on the total heap. And the only use case is you have multi CPU. You can use all types of Linux, Windows, and basically this is used for larger heap size when many objects are created and deleted. So when the last point, if you take this last point, many objects created or deleted, the frequency of allocation, the frequency of creation and deletion should be almost equal. Objects are getting created. If they are not getting deleted, the memory gets filled up. The more GC will happen, right? So then you will start seeing the issues. So even throughput collector is not being used. Okay, even the parallel GC, parallel load GC is not being used. Till last 2 years, majority of the people used to make use of this CMS, concurrent mark and sweep. What does it do? Basically, the main advantage of using concurrent mark and sweep is it will not have long GC process. It will not take much time for major GCs and full GC cycles. Even for the minor GC, right? Not only concurrent mark and sweep, all the algorithms, even when the minor GC is happening, all the application threads will stop. Even for minor GC, there will be stop the world event. Stop the world event will happen. But the reason the application will not hang is because in the minor GC, it will not even take 1 second or 0.9 seconds, 0.4 second at times, so that it will execute very quickly. It will not take much time. It will be very faster. That is why the reason it will not have any performance impact. Okay, and when you use this concurrent mark and sweep collector, the only thing that happen is uh, young generation, for collecting the garbage in young generation, it will use a different algorithm. It can be anything. Mostly it will use the new GC, sorry, the parallel GC that we discussed just now, right? Throughput collector. It will use the throughput collector for collecting young generation, and it will use the CMS collector to collect the total older generation. Okay, so basically this will not perform any compaction. So that is why the reason most of the people still, the legacy applications which are created, they still use this particular case, CMS. It does garbage, it actually do garbage collection only for the older generation. If I ask you what is the difference between parallel, serial, and CMS, parallel, serial, throughput are almost same. Parallel is also called throughput. In parallel, you have parallel old GC and parallel new GC. Both are same with some minor changes. They call it, we have five different GC algorithms. The first one is serial. The second one is throughput collector, which is also called parallel GC, parallel old GC. They don't have a big difference. They are now using parallel GC. In fact, they are not using serial and throughput collectors. Still, many of them are using concurrent mark and sweep. The only difference between serial throughput are almost same, no big difference. Okay, like throughput collector will use some 64-bit JVMs, and it will work on multi-core, multi-CPU environment. Okay, so but whereas in CMS on the young generation, it will use a different algorithm, and the older generation it will use CMS. Okay, and the only big difference is it will not perform any compaction. That is the only difference. Got it? It will not do any compaction. So concurrent itself is nothing but concurrently it will do all the activities. Okay, so This garbage collector is mainly suitable for responsive application where we can't afford, or when the customer is saying that I don't need any longer pass times. If you want to limit the number of threads in CMS collector, I don't want any longer pass times, then you can use CMS and you can give a try by using concurrent mark and sweep. Okay, so basically it is designed to eliminate all the long passes. You will not have any long passes and it will not perform any compaction. The only requirement for using CMS is only to minimize the pass timings, GC pass times, and stop the world event timings and the major GC execution time. In case of high single CPU machine, they saying that use CMS incremental mode. This is not required. No one is using it. Okay. Now, the last concept is the G1 GC. Where is this? This one. This is, if you talk about G1 GC, it is available from Java 7 and it is a long-term goal is to replace the CMS collector. Slowly people stopped using the CMS collector and everyone now is using G1 GC collector. Every developer, every performance engineer knows the unique feature and importance of G1 GC without even thinking about, without even looking back about CMS or serial GC or what garbage collection that is used earlier. Now currently people started using G1 GC. So that is one advantage. The G1 GC is parallel, concurrent, incrementally compacting, low pass. It has many features actually. It does not work like any other collectors. There is no concept of looking at Tang first, going to Eden, then checking the Survivor 1, Survivor 2, then going to check older generation, then it goes to PermGen. It is not like that. Whichever memory is getting filled very quickly, it directly attacks, it directly get kicks, it directly uh, it kicks in and it will start performing the activity and it will try to reclaim the memory of any area from the heap. It will not wait for the process. First I have to check Eden, then I have to check S0, S1. It will not wait for all of them. It divides the heap into multiple equal sized heap regions. When a garbage collection is invoked, it first collects the region which has lesser live data. Okay, that is why the reason it is called garbage first. Got it? And the JDK8 has some sample applications. If you try to install Eclipse, if you install the Java development kit, you have some demo applications where you can use some sample applications. You can use JStart command. When you go to Java monitoring, right, you can go to JStart command and you can execute this sample program, and you can also use JVisual VM. You can use Dynatrace, AppDynamics, any other tools. There is also JMC flight application, right? If you go back, see Java.
Okay,
Yes, sir. 1 minute. Yeah, tell me.
how to identify that which type of GC is using in our application? Where to check that?
That is set environment while set env file was there in application server. I'll show you that when I show it to you in real time, because we'll set all these metrics, right? I'll
Hmm.
show you that file.
Okay.
You can also use JMC, right? Java Mission Control. See J console, J command, J stack. Oh my God. Secure connection. All right, madam. Here you can see, I think I have already showed you, right? Heap memory, if you take heap is utilized like this and non-heap is like this. Does this? You can select the drop down here, G1 old gen, okay, the meta space, G1 survivor space, You can look at all these things here. Threads, VM summary, we can look at. Yep. What happened to JMC? And there should be some sample flight application. Okay, if you record this sample flight application, even this will help you. There are so many other things. Don't know how it got recorded yesterday. There is no file now. Okay, if you go here and see, it will directly give you all the VM summary will give you the process ID information, the type of virtual machine that you're using. This is the vendor, the name, the uptime is it is up from 8 hours, process CPU time is 2 minutes, and Git compiler time it is giving you 1 minute. We have live threads, peak threads, daemon, non-daemon, current classes loaded, unloaded. Then you will go to unloaded and see why they are unloaded. Okay, this is one investigation. Now, if you look at the garbage collector, what it is saying, G1 young, G1 old. The algorithm that is used currently on this JVM is G1C, G1C algorithm. Collections are 35, total time spent is 0.69. If you look at this one, G1 old generation, collections are 0. Older generation, you don't have anything. Total spend time is 0 second. Okay, the number of processors depending upon the committed virtual memory, physical memory, 1/3 of the memory will be given as heap. Okay, you need not. How many of you have seen this PT memory basics document? Did anyone get a chance to go through that document? No one? Okay, so even if you don't have time to read all of that stuff, understand what is virtual memory, committed virtual memory, what is physical memory, free physical memory, total swap, free swap. Understand these things at least. Okay, so overview is like this. Okay, heap, threads, classes, and CPU usage. Did you see the spike here? What is this? The spike is only 3%. That's fine. See, for everything, if you search for the right blog, for everything you have a solution. Okay, if you're at the right place, you can. Many people I see actually they keep asking me the same question, sir. Even most of the inquiries that I get when I start giving demo or when I teach many performance sessions in many organizations, they ask me, sir, how to get real-time knowledge? How do you get it? What will happen in real time? What are all the different issues that I can see in real time? I want that setup. I want that access to practice. You know one thing? You can create your own setup. You can download one sample Java application. You can create a free open source Apache Tomcat. You can create WebLogic 12c generic installer app server. You can download Oracle 12c. You can download the application war file. In the application war file, you will have the application name dot properties. Buy a machine on Contebo or any cloud vendor, buy one Linux machine. It is like you can think like you're spending some 600 to 800 on Swiggy per month for a single month. So it will not cost you more than 1,000 rupees buying two machines from this one. Oh, what happened to this one? Okay. So this is an IIQ.properties file. You know what this property file is? This is the application that I have installed. Okay. If you look at this properties file, are you able to see my screen? The font is very small, right?
Yeah, we are able to see. Okay.
But the font is okay, right?
It is okay, not that bad.
All right. Thank you. So So if you look at this part, did you see here? This is the properties file. In this application, you need to set these properties of the database that you are connecting. The first one is MySQL data source properties. If you see, forget about the max wait milliseconds, max total, and minimum idle. But if you take the MySQL Aurora without SSL is one configuration, with SSL is one configuration. But the configuration that I have done for my machine is Oracle. Okay, so Oracle is, if you look at this one, the data source URL is JDBC Oracle Thinnet localhost 1521 is the port name and my application name, and this is the driver name that I have given. Okay, the session factory hibernate properties is org.hibernate. This is an application property. If you are giving these properties and saving it, what does it mean? The application that you deploy on your web application server is now connected to Oracle database, and every application can be configured to number of databases. Here I configured to Oracle. The same application I can configure and I can establish the connection to MySQL server, right? I can also establish the IBM DB2. If you see here, DB2 host name, port number, database name, and data source URL is this one. If you are installing it on localhost, or if you are installing it on any other machine, this is my remote machine from cloud. So I have, I can give the machine name here, I can give the port number and driver class name, and I can give the connection establishment. To reflect all these changes, I'll restart my Oracle database or MySQL IBM DB2 database to check whether the connection is established or not. If you look at this start WebLogic EMD CMD GC, hang on for a moment. This is one of the file from WebLogic server. Yes, someone asked me the question, right? What happened? What happened? Mm-hmm. Sir, how many of you are seeing set?
Yeah, we are able to see.
This is which one they're using now?
No, I didn't get you. Set,
Which algorithm they're
yeah,
using now?
G1 GC, G1.
Use serial
Yes,
GC
G1.
is like enabling serial GC. Okay, set domain environable is like, because this application server is not completely loaded, so let me reinstall it. I am not using this machine from so many days. Again, I have to deploy some application on this one. Again, that's what you can create your own setup, but all you need to do is you need to spend some time. You need to invest some time. The first thing that you have to do is you have to search for a sample application. So you need to understand what is a war file. If you are getting a sample Java application, you need to get the steps on how to install, how to deploy on web application server, and how to connect that application to database server. Once you connect all of them and once your application is up and running, you can give the simple application name followed by port number, and you can access it from any of the browser. Even sitting from your office, if it is an internet based application, you can directly access it. What you can do, you can install LoadRunner 2020 version, which comes with 50 concurrent users license. You can prepare a script and you can run some scripts. You can install Sitescope, or you can install Prometheus or Grafana or any open source monitoring tool like Nagios. Configure this monitoring tool with the web server and Oracle server. Try to fetch some metrics. This is how you will get real time. Got it? Just spending some money on a course is fine. You'll get some sufficient knowledge, but if you want to get some good hands-on experience on all the activities that I'm showing, you yourself has to take some initiation on creating an own setup, and you need to do some kind of R&D. What a JVisual VM will do, how can I get the process IDs, how to monitor, how to do all this stuff, and you need to do all that stuff, right? Okay. So any issues you can always call me after 8 o'clock in the evening. You can ask me any questions with respect to any of the engineering activity, any assignment, I can support you. And we have one last point. When we talk about the GC tuning part, only two things: increasing the heap size. One is increasing the heap size. What else you can think of?
Moving to G1GC.
Using G1GC,
Yes.
never specify a heap more than amount of available physical memory. I told you, right? 1/3 of physical memory will be your heap.
Yeah.
And if you still want to learn more about garbage collection, you need to learn about allocation rate. Okay. So basically this high allocation rate, right? Excessive high allocation rate can be a very big trouble for any of the application performance. When running on any JVM, the problem will be revealed by garbage collection overhead metric. There is one metric which will clearly tell you the allocation rate of the objects. Is it high? Is it low? So how do you measure allocation rate? It is very simple. You need to turn on GC logging by specifying XX print GC details and print GC timestamps flags for the JVM. There are two metrics. I'll send you the document. You have all of them in that document. Now what the JVM will do is it will start logging all the GC passes inside the JVM. What is logging? What is a log?
Log
No one
is
knows
like
what.
log is like when the GC is executed, exactly like what is happening, it will write it. I mean, it will give information outside console.
Okay.
It's like for
Okay.
debugging, or it's like for understanding when the code is executed, what is happening.
See, thread dump, heap dump, enable logging. Even if you take the log in the load runner, advanced logging, right? Advanced trace, data written by the server, and what's the other option?
Parameter substitution, extended log, as part of the extended log.
Extended log, parameter substitution, data written by the server, and advanced trace, right?
Yes.
This is nothing but any log file. What it will do is it will completely record the communication between the server and the client. Whatever the communication that is happening, it will capture all of it, and it will give the detailed information to the user who is investigating. It can be a performance engineer, or it can be a developer, or it can be anyone who is trying to understand what happened. Okay, so you need to understand this allocation rate, and this allocation rate, right? The allocation rate from the GC log, we can calculate the allocation rate by knowing the different sizes between the young and older generations and perm generations. So there are few applications so which can tell you how the JVMs will be affected. Demo applications we have. So allocation rate can be reduced only by reducing the frequency of GC pause. So how will you reduce the frequency of GC pause? So I will use CMS because it will not have longer GC pauses. No, it is not the solution because GC pause time has to be optimized, and it is not you again who will optimize it. And why the reason why you are considering this allocation rate is because you should be very much worried about your throughput. If your throughput starts decreasing, it is a gone case. You're running a test for 8 to 9 hours, you see the throughput constant, or throughput has to constantly increase, right? Throughput is nothing but the amount of data that we retrieve from the server. For every request that we make, some data you get it from the server, right? So every time you buy a policy, you will you need even you buy a IRCTC ticket in the Indian railway system, you will get a ticket in the form of data. That acknowledgement is nothing but you are getting some data in the form of printed ticket. Again, it is data. It is called throughput. Every user is buying a ticket. Every user has to get a ticket in the form of data. So when users are increasing, when users are continuously buying something, eh, for example, if they are buying an insurance policy, some 200 pages of booklet with terms and conditions will be downloaded, which is of some 15 MB size. For every user, if he is downloading 15 MB of document, if the users on the applications are increasing, the throughput has to be increased. The throughput has to increase, right? If the throughput of your application starts to decrease, then there is a problem with the allocation rate. Object allocation rate is very, very high, and application is creating too many objects that are almost immediately discarded. Then you have to look at all the minor GC, major GC, and you need to look at the load and how the GC is having some impact on the throughput, how it is affecting the performance. And the last point with respect to allocation rate is premature promotion. Premature promotion is nothing but there are chances of there are few situations where some of the objects will not undergo the 15 minor GC cycles that has been set from a value. After 8 to 9 cycles, the objects get promoted to the older generation. What does it mean? It is a flaw, right? It is some abnormal behavior of an object. So promoting long-lived objects from the younger generation to older is how JVM is expected to behave, right? So whenever you get some object, the long-lived object should get promoted from younger to older. So what here is objects which has very short life are not collected in the younger generation, and without undergoing all the number of GC cycles that you said, they promoted to older generation. This is called premature promotion. Premature promotion should be 0. Okay. If the premature GC is high, it means that objects are automatically getting survived even if they are no longer being referenced, and which is creating a high performance impact and high stop the world event passes. Got it? This is all about GC, and if you have any questions, you can come back to me. I have to start to office within 10 minutes. If you have any questions, we'll clarify tomorrow. You can, meanwhile, you can go back, look at the document, and I strongly suggest all of you to read. Okay, read from the basics. Write a notes. Make some points handy. When you write all of these things before you go for an interview, you can just open that book, what you have prepared, what you have written. It will be easy for you to explain the issue very in specific. Still, I see many people answering me questions in a way. It is you who is driving the interview, right? I still keep asking this question, even if he's a architect, some kind of high experience. I still ask this question: what is the difference between smoke and sanity? Some people say that when I ask what is sanity, it is a subset of regression. My immediate next question would be, what is regression? So depending upon what answer you give to the interviewer, it is you who is driving your interview. So whatever the question that the interviewer is asking, you need to be very specific. You need to come up with a logical conclusion with a right real-time example, which will increase your package from 6 lakhs to 16 lakhs. There are cases. If your interview is very basic level, or you are selected, but I did not feel you extraordinary. You ask me, sir, I'm working from 8 long years in TCS and I'm getting only 6.8 lakhs. I'm expecting 15. I cannot give you that. If my requirement is immediate, if I feel you as the right fit, and if I feel that your interview is extraordinary for your experience, I see people some 4 to 5 years from product-based companies like ServiceNow, and they come from Salesforce. They only talk about engineering activities. My company is now paying for 4 to 5 years performance testing and engineering. 22 lakhs they are paying. Trust me. So this all depends on how you prepare your interviews, how you have to prepare the concepts. Out of 10 years, 13 years experience you have, when you call yourself as I have 6 years of relevant experience in end-to-end performance engineering. Now my questions are very different when you yourself is calling 12 years of core experience in performance testing and engineering. So accordingly you prepare. At the end of the sessions, anyway, I'll help you with some list of questions, some 90 to 100 questions from performance engineering. And don't by heart, don't read. Come with some real-time cases. Explain the scenario, some bottleneck, some deadlock scenario. Give us a justification how you fixed that. With that fix, what improved with what changed with what changed with what. You have to explain all of them for a better learning. Okay. All right, we'll meet tomorrow. Thanks all of you for joining and thanks for your time. And tomorrow
Yeah.
we'll start with thread dump analysis. Okay.
Okay. Thank you.
Thanks.
Okay, so thanks.
Thank you.